Okay, boys and girls, we're going to go ahead and get started. What is this? Some people tell me it's zeros and ones. Some people tell me it's a string of numbers, but it is actually binary code. Binary means two. There are two options here, a 0 or a 1. The zeros are representing my offs and the ones are representing my ons. But this actually says something. Let me organize it into more readable lines. So each of these is now organized into a byte of information. This top black one is a one-letter word. This second one, the gray one, is a space. Then we have a four-letter word. Letter, 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 letter. We have another space. And we have a three-letter word. I have another hint coming up in the background. Do you have a guess as to what this says? This is the binary code for I love you. So this top black one is the code for I, space, L-O-V-E, space, Y-O-U. This is how computers tell each other that they love each other. This is the inside of a desktop computer. You can see lots of wires. So electricity is running through it. And in the wires, you can either have the electricity flowing where it's on or not flowing where it's off. And that is how the computer communicates. Ons and offs can be represented in different ways too. In the top left, we have a hard drive. Hard drives store data magnetically, so we would have pluses and minuses. In the bottom right, we have CDs or DVDs. These are optical media. They have reflective parts and parts that don't reflect the light. So the shiny and the dull could be your set of opposites for that. So binary can be any set of opposites. Let's look some more at this with a video from code.org.
This is the binary bracelets lesson. We are going to code our initials on a bracelet that we can wear
and show all our friends. You look good.
K and then C. So K has 8 digits.
Binary is a way of representing information using only two options. Sometimes people think of this as only ones and zeros, but you can represent binary with combinations of on or off, up and down, in and out, or really any set of opposites.
Hi, I'm Orion, and I program robots here at PlayEye. All computers and robot brains at their most fundamental level are little electronic gates. And when the gate is open, electricity can flow through, and when it's closed, electricity can't. So an example of binary on the robot is the robot's eyes. The robot's eyes are LEDs, and those are lights that are either on or they're off. It's a binary system, one or the other. We can use the lights to represent binary numbers. So if we have a set of robots, we can say that the first robot is the ones place, the second robot is the twos place, the third robot is the fours place, and so on. And that's how you represent a binary number, and the robots will do it with their binary eyes and count it out for you.
He said that in binary, it's a system of twos. So this is the ones place. Then we're going to multiply that by 2. This is the twos place. We're going to multiply that by 2. This is the fours place. We're going to multiply that by 2. 8s, 16s, 32s, and we could keep going. 64, 128, 256, and so on and so forth. So if I wanted to represent the number 1, I would light up the 1 in the ones place. The 1 is on. If I wanted to represent the number 2, I would light up the one that's in the twos position. So the 1 has gone off, the 2 has come on. That's how I show 2. And you can see here the counter. This is the number as we normally see it, 2. And this is how a computer would see it. All of these are offs except for this on right here. And then we go off again. So how would 3 look? Well, if this is the fours place, I don't need it yet. 2 and 1 is 3. So when I have these together, that shows the number 3. So I have 2 ons here. Let's talk about the number 9. What would that look like? Well, I would need my 8's position plus my 1's position. 8 and 1 is 9. How would I show 15? Well, if I'm counting 1, 2, 4, 8, 16, that would be too big. I actually need everything in front of it to get me 15 because 8 plus 4 plus 2 plus 1 equals 15. Let's try one more. How would I show 24? For 24, I'm going to show the 16's place and the 8's place because 16 plus 8 is 24. You can also use this to represent letters. So here we have the blacks representing offs or something that's dark, and we have the open squares representing our ons, something that's light. So I'm going to put up some symbols here, and I want you to figure out the letter that's associated with it. This is just matching. So in this one, I have off, on, off, off for this first part of it. So let's look through. Do you notice a pattern here? A through O all has that pattern of off, on, off, off. And then P through Z has a different pattern for the first half. They go off, on, off, on. So as I mentioned earlier, this is a byte of information. Each one of these is a bit, a binary digit. And when you have 8 bits together, you have a byte. Techies have a sense of humor. They call half a byte a nibble because a nibble is a small bite of food. So the first nibble is the same on A through O, and this matches that first nibble. So now I need to look at the second half. Off, on, off. I'm going to look through. There it is. Off, on, off. So this byte that I put up matches the same one in my code here for the letter F. So this first one is an F. All right, now that you understand, let's try some other ones. What would this letter be? Well, if I look at the first half of my byte, I can see that it matches in the P through Z section. So now I'm going to look at the second half and see which one fully matches. It's the letter R. What about this one? That matches the letter O. What about this? That matches the letter G. Let's try one more. That matches the letter S. So we have spelled the word frogs.